Hi class, welcome to Chapter 2, Guidelines for Designing a Healthy Diet. This chapter is mostly going to talk about government-based recommendations for general healthy diet versus specific recommendations for individual healthy diet. We'll get to discussing specific recommendations for individual healthy diet later on in the quarter. So, nutrient standards and recommendations. Nutrient standards and recommendations let us know how much of each nutrient we need. And so they can guide us to determine how many calories we need, how many vitamins and minerals we need, how much protein we need, how much carbohydrate, how much fat, etc. And these standards and recommendations are guided by the creation of many different terms. The first set of terms that we're going to discuss is called the dietary reference intakes. And the dietary reference intakes are a set of 4 terms that can guide us for different nutrients. They include the RDAs, the AIs, the EARs, and the ULs. And we're going to talk about those coming up. Complementary to the DRIs are the AMDRs, or adequate macronutrient distribution ranges, and these have to do with what percent of calories should come from protein, fat, carbohydrates, and then the estimated energy requirements, which are individual calorie recommendations for different age groups, genders, activity levels. So we're going to be talking about all these terms today, as well as quite a few more. And it's very good to know the difference between each term. I would recommend perhaps making flashcards with these abbreviations and a little explanation of what each of them means on the back. So to begin with, we'll start talking about the EAR. And the EAR is estimated average requirement. So this could be the average requirement for calcium or the average requirement for iron. And this is expected to meet the needs of about 50% of the population in a specific life stage, such as toddlerhood, such as older age, and specific genders. So you'll have a different EAR for men and women. The EAR is set if there is sufficient scientific evidence to estimate the average needs of about 50% of the population, and we have EARs established for 17 nutrients. If we are able to establish an EAR, we can then create something called an RDA. So EARs are the foundation for the RDAs, which are recommended dietary allowances. And unlike the EARs, the recommended dietary allowance will meet the needs of a much higher percentage of the population. So almost all of the people in a certain age group and life stage and gender, their needs, for example, calcium, iron, vitamin D, will be met if they're consuming the amount recommended by the recommended dietary allowance. The goal of the RDAs is that deficiency and disease will be prevented if people are consuming nutrient amounts within the RDAs. And this will apply, like I said, to the majority of the population. The EARs and the RDAs are both evidence-based, so that's something important to know. AIs are slightly different than the EARs and the RDAs, and I like to remember the AIs as meaning artificial intelligence. And I think of artificial intelligence as being not quite as strong as normal intelligence. And so what I mean by that is the adequate intake levels are not based on sufficient research. So there is sufficient research to establish the EARs and the RDAs, but the adequate intake levels do not have sufficient research, and they more represent our best educated guess on how much of a specific nutrient will meet the needs of a population. But it's really an educated guess versus actually scientific evidence. Consuming levels that meet the AIs should help maintain growth, should help maintain normal levels of the nutrient in the blood, and should generally maintain health, but they're not quite as strong as the RDAs and the EARs. UL, or tolerable upper limit, is the official term, is the maximum of a nutrient that you would want to consume on a regular basis. And anything more than that could cause adverse effects or toxicities. So the UL is kind of like the highest level that you would want to take or exceed. Above the UL, you're going to see more risk for toxicity. The UL is not necessarily a goal, so you don't necessarily want to strive to meet the UL. You really want to strive to meet the RDA, but the UL is a maximum. And for most nutrients, the UL includes intakes from all sources. And when I say all sources, what I mean is food and supplements. And supplements could be powders, vitamins, fortified foods, bars, etc. There are a few exceptions to this, and those are nickel, magnesium, and zinc. So those do not necessarily include food and supplements. They're just one or the other. Okay, I have a few different graphs coming up, and these graphs can help depict the relationship between these different levels. So on the left-hand column, we have percent of healthy population at risk for inadequacy. So that would be percent not getting enough. And so what's not shown here is the EAR. So I'm just going to do this, and right here would be the EAR, and excuse my writing, but my pen is not very great on this computer. So right here would be the EAR, right about here. And right about here, we would be meeting the needs of about 50% of the population, because we have 100% up there. I'm going to clear that now. Then right here is the RDA. The RDA is going to meet the needs of about 97 to 98% of the population. So with the RDA, what you can see is that there's only this tiny little percent here that is at risk of inadequacy. And this tiny little percent represents like 2 to 3% of the population that's at risk for inadequacy. So not very many people at risk for inadequacy. Somewhere between the RDA and the UL is the AI, and this picture shows it being exactly between, but it's not necessarily exactly between, because remember, the AI is our best guess of adequate intake needed to sustain health. And then on the right side of this, we have the UL, or the tolerable upper level. So anything above the UL, which the UL starts right here, anything above it, the higher above the UL that you get, you're going to have a higher percent of the population at risk for toxicity. So below the UL, you have very, very low chance of toxicity. All right. Let's go to the next drawing. This is a similar drawing. This particular one has the EAR pictured, and you can see the EAR is intersecting this line at about 50%. So 50% of the population is going to meet needs. The other 50% is potentially going to be inadequate. The RDA is going to meet the needs of 98 to 97%, with just a small percentage of the population at risk of deficiency. The AI, this is probably a more accurate picture because it's not exactly in the middle and the line kind of fades out. And that's representing the fact that we don't know exactly where the AI should be, but it's a likely level to meet needs of healthy population. And then the upper limit, and anything beyond the upper limit, you see a higher risk of toxicity. Next set of terms. So the terms that we just talked about were the dietary reference intakes. And now we're going to talk about a different set of terms. So we have estimated energy requirement, and estimated energy requirement is how many calories you need a day. And there are actually calculations you can do to determine this more specifically, but there's also tables, and you can find some tables in your book. The tables are based on different things because not every single person is going to require the same amount of energy. And so they're going to take into account height, weight, gender, activity level, age, and growth phase. So maybe are you an infant who's growing rapidly, or are you a pregnant woman? Or are you a teenager, perhaps going through puberty? Or are you middle-aged and not necessarily growing? So the EER will estimate our calorie need, and it's specific based on those factors. The AMDRs, remember I said these were complementary to the DRIs, and the AMDRs specifically talk about macronutrients. So the DRIs are going to talk about our vitamins and minerals, and the AMDRs are going to talk about our macros, our carbs, our protein, and our fat. So, for example, the AMDR for calories coming from carbohydrates is 45 to 65%. The AMDR for fat should be 20 to 35%, and the AMDR for protein should be 10 to 35% of your calories. These are general recommendations, remember, by our governing bodies, and they are based on scientific evidence. However, that does not necessarily mean that every single person has to fall within those ranges. And I know there are many people who will not be in those ranges. Perhaps they're going to have lower percent of calories from carbs, higher percent from protein, higher percent on fat. And that doesn't mean that they're following a bad diet. It's just a different diet from what's recommended in the AMDR. And so those can be healthy diet patterns. It just depends on how they're planned and the individual's needs. Next, daily values. So the daily value is a term or a set of standards used specifically on food labels. So if you've ever purchased any food, which I expect you all have, you might notice that food has a nutrition facts label on the back. And here you can see that the nutrition facts label has this thing right here, percent of daily value. And you might be saying, what the heck is a daily value? Well, we designed the nutrition facts labels to be based on a daily value so that we could generalize what percent of a food would contribute to nutrients for the general population. Because remember that the RDIs are based on age, gender, etc. So if we were going to list the RDIs on a nutrition facts label, we would have to have all sorts of different labels for so many different people. You know, we would have to have sodas for women, sodas for men, sodas for toddlers, sodas for teens, because they would all have different labels. But we created the DVs as kind of a universal standard or a generic standard because we can put them on a label and they give us kind of a general goal. So the daily values are for people age 4 or higher, and they do not apply to toddlers, infants, or pregnant women. And the daily values are based on a 2,000 calorie diet, so that's important to know. And they are also based on 2 more sets of terms, so the RDIs and the DRVs, which we're going to talk about on the next page. So the daily values are based on the RDIs and the DRVs. Trying to go to the next slide, and it is not letting me. Okay. Hold on. All right, I got the slide to advance. Sorry about that. So the daily values are based on the RDIs and the DRVs. The RDIs are specific for vitamins and minerals, and therefore nutrients that have established nutrient standards, such as the RDAs. And so generally speaking, the RDIs are higher than the RDA. And this allows the daily value to be based on a higher level than the RDA, which means people are more likely to get enough of the nutrients that they need when they're looking at the food labels. Many experts believe that the RDIs should be revised because, as you can see, they're based on very old RDA levels, and many RDA levels have been updated since the 1960s. The daily values are also based on the DRVs, and the DRVs are for the macronutrients and energy, as well as a few of the micronutrients such as sodium and potassium, as well as cholesterol. So most of the DRVs are not necessarily based on the RDAs, although there are RDAs for sodium and potassium. Next, so the next thing is talking about nutrient density. And nutrient density is referring to how many nutrients or how much of a certain nutrient a food has compared to the amount of calories in that food. So you could probably look at these two beverages and take a very obvious or educated guess which one might be more nutrient dense, meaning having the most nutrients. So we have a soda on the left and we have milk on the right. As far as nutrients go, you can see the soda only has calories. The milk also has calories, but it's less. The soda has no protein, no vitamin A, no vitamin C, no thiamine, riboflavin, niacin, calcium, or iron. So really, the soda has no nutrients except for calories. And a food is considered nutrient dense if it has the highest amount of nutrients per calorie. So high nutrient levels, such as really high calcium in milk compared to low calorie levels. I would consider the soda nutrient poor because it has zero calcium and high calories. And so sometimes foods are obvious like this, and you could eyeball them and take a guess which is more nutrient dense, and sometimes it's a little bit less obvious and we actually do a calculation. So the calculation is shown on the next slide. So how would we calculate nutrient density? And you should be able to calculate this for your midterm exam. And so in order to calculate nutrient density, you need to know a few things. You need to know the amount of the nutrient that's in the food, and you need to know the amount of calories that are in the food. So, for example, in this particular glass of milk, there are 500 milligrams of calcium, and every day it's recommended that we consume 1,300 milligrams of calcium. So we divide 500, which is in the milk, by 1,300, which is recommended for the day, and we get a decimal, 38.38. In order to convert that to a percent, we multiply by 100, and what we find is this one glass of milk has 38% of our daily calcium. So that's pretty good. The soda, on the other hand, had 0 milligrams of calcium, so the soda had 0% of calcium. Next, we can figure out what percent of the daily calories the milk provides. So in this glass of milk, it had 150 calories. Based on that, I'm going to guess it's whole milk versus fat-free milk. And so you divide how many calories are in the milk versus the average for the day, which is 2,000. That's a daily value number. You get the decimal again, 0.075. You multiply it by 100 to convert by percent, and you find that this milk has 7.5% of your daily recommended calories. The next step is to compare the two. And you don't always have to do this, but this can be helpful when comparing one food to another. So what I mean by comparing the two is taking the percentages and dividing them by one another. So we have 38% of calcium, and we can divide that by 7.5% calories. And we're going to get, I believe, 5.1. And so 5.1 is an indicator of the nutrient density in this, particular food. My mouse is all over the place. That should say 5.1. So then if we wanted, we could compare this nutrient density to, say, the nutrient density in fat-free milk. And I could tell you that fat-free milk is going to provide a lower percent of your daily calories. So fat-free milk would actually be more than 5.1 or more nutrient dense than full-fat milk. All right, next, I need to get rid of this. Okay, things that are low cost, nutrient dense foods that would be good foods to eat include the following listed there. So fat-free milk, beans, fruits, vegetables, lean meats or lean protein foods, legumes, fortified cereals, etc. And things that are not nutrient dense would include things such as chips, sodas, cookies, candies, I don't know, sugar sweetened beverages, ice cream. Those would not be nutrient dense. Next, we're going to look at energy density. And remember that nutrient density looked at a nutrient such as calcium or vitamin D or iron. Energy density looks at energy, and we measure energy in calories. So energy density is going to look at the calories in a food per the volume of that specific food. So we're going to hold the volume the same. So example, with the beverages like milk, we're going to compare an 8-ounce cup of skim milk to an 8-ounce cup of whole milk. And you could take a guess which one has higher calories or higher energy. It's going to be the whole milk because whole milk has a lot more fat. So whole milk would be more energy dense than skim milk, but skim milk would be more nutrient dense than whole milk. High energy density foods are foods with a lot of calories. So candy, soda, potato chips, fried foods, peanuts, bacon. And then low energy dense foods are foods with low calories per volume. So lettuce, strawberries, grapefruit, most of the fruits and vegetables, skim milk or fat-free milk, water would be very low energy dense. It's possible for foods to be both energy dense and nutrient dense. So peanuts I do have as energy dense, but peanuts are also nutrient dense because they have fiber, lots of vitamins and minerals, and protein. Using energy density to determine which types of foods you want to eat can actually be a really good strategy for weight loss and portion control and dieting, and also can have a good relationship with satiety. So for example, the top picture is showing a stomach and different foods filling the stomach. Oil is very energy dense, meaning there's a lot of calories for a small volume. And so oil only fills the stomach a little bit. And if you were to eat oil or eat fats, you might not feel very full. The middle example is chicken. Chicken is a little bit less energy dense than the oil. And so you can have a higher volume of it for the same amount of calories. And then vegetables are not very energy dense. So you can have a huge volume of vegetables for a relatively low amount of calories. And you can see this at the bottom as well, where we've got jelly beans, some chocolates, grapes, apples, and cherry tomatoes. And these are all 100-calorie portion. But with the cherry tomatoes, the volume in 100 calories is so much more. So you could eat all those cherry tomatoes and you might feel more full than if you just ate these like 20 jelly beans. So lots of people will choose foods that are high in volume but low in calories, such as lettuce, salads, watermelons, fruits, vegetables, etc. versus high calorie foods like ice cream or candy or sodas to help them feel more full without having to consume so many calories. Next, we're going to talk about the nutrition facts panel, and I did hint to it a little bit when we were talking about daily values, and you actually saw our current nutrition facts panel. The nutrition facts panel is based on what they say typical American serving sizes are, and I put typical in quotes because I personally think that the serving sizes on the current nutrition facts panel are a joke, and most of them are very inaccurate and underestimate how much people would actually eat. But we'll get into that a little bit later. So this is the current nutrition facts panel. And when I say current, I'm saying that because there's actually a new revised nutrition facts panel coming out, hopefully very soon. So things that are on the nutrition facts panel, the serving size, this would be 1 pouch or 1 box of the macaroni, the servings per container. This is where I think it's a little bit ridiculous. So it says 6. Who would split 1 box of macaroni with 6 people? I know I wouldn't. Usually, if we cook macaroni in my house, it's between 2 people. And sometimes if my teenager eats it, it's 1 person and he'll eat the whole box. Only if my 2-year-old eats macaroni does it last 6 servings. So I personally think that the current serving sizes are ridiculous. Other things that are listed: total fat, cholesterol, sodium, carbohydrates, protein, and then currently vitamin A, calcium, iron, vitamin C. It also talks about this being based on a 2,000 calorie diet. And then you can see the ingredients listed. The ingredients are listed in the highest amount first versus the lowest amount last. So in this macaroni and cheese, the thing that there's the most of is enriched macaroni product. And then the thing that there's the least of, thankfully, is yellow number 5. The new nutrition facts label. So on the far left is the label that we just saw, or the current nutrition facts label. And then on the middle and the right are the new nutrition facts labels that are coming out. There's some really cool changes coming with the nutrition facts label. For example, the calories are a lot bigger, and the serving size is specified. So it says amount per 2/3 cup, 230 calories. The daily value has been shifted to the left side. And you can see there is this new column or new row for added sugars. So this way you can look at the total carbohydrates and know what part of those carbohydrates were added. And added sugars we're going to talk about in our carbohydrate chapter, but these are literally sugars that have just been dumped into the food that don't occur naturally. Next, you see the vitamins and minerals, and there are different vitamins and minerals than there previously were. So you don't see vitamin A or C, you don't see vitamin A or C, but you do see vitamin D, you still see calcium and iron, and you see potassium. Potassium is a nutrient that in general we're not getting enough of, and so they put this on the nutrition facts label to try to encourage people to consume more. Other things. So this label in the middle of the page is a label meant for foods where there are so many servings that you would not eat the entire food at once. The label on the right-hand side is meant for foods that it would be possible to eat the whole serving at once. So generally the serving sizes for this double columned label on the right are for foods that have between 1 to 3 servings. And my example of this would be you're driving, home for the weekend, you stop at the gas station, you grab a bag of chips. Generally speaking, those gas station bags of chips are not just 1 serving, they're 2 to 3 servings. And do you eat just 10 chips and then put the bag away and save it for the drive home? Not usually. Most people will eat the whole bag of chips. So these double columned nutrition facts labels have the amount in 1 serving, but they also have the amount in the whole container. And this was a move by our government to try to create more awareness of how much people are actually eating without forcing people to do math. So before, you would have to look at the calories per serving, the nutrients per serving, and say, okay, if that's in one serving and I eat 3 servings, what's 3 times 220? And do all the math yourself. Well, that's kind of an advanced level of thinking and reasoning that most people aren't going to bother to do. So with this double column food label, they have done it for us, which is really nice. Oh, let's go back here. When will this label come out? This label was supposed to come out in July 2018, and I have seen it on some products. I've bought edamame that I did see this new label on. I've seen it on mochi ice cream that I bought at Costco, but it's not on all products yet. The government actually rolled back the mandate to have this out, and they've extended the due date to 2020, January 2020 for large companies, and January 2021 for companies that make less than $10 million, which they're considering small companies. Just to note, this nutrition facts label has not been revised for 20 years. Actually, it's going to be more than that by the time it rolls out. And so the original portions on these labels are over 20 years old. With the new label, they are changing the portion sizes to be more realistic. And so we're going to see some portion sizes coming up and kind of looking at older portions versus current portions and why this is important. So, portion control. Portion control is probably one of the best ways to moderate weight. And portion expansion is possibly one of the things that has contributed to our society's weight gain. So again, I said those nutrition labels were based on portions from 20 years ago. And so 20 years ago, the portions were much smaller. A hamburger, 330 calories versus today, close to 600. Pizza, pasta has doubled in calories. Soup, that's like 7 times as much calories in a soup. Muffin, who's bought a Starbucks muffin or a Costco muffin, those are just loaded in calories. You only get to eat 1/4 of the muffin to have it be what actually is a serving. Cookies, hugely increased in calories as well. More pictures of portion distortion. So in the past, what would have been a portion or what should be a portion based on the nutrition facts label, you only get half of this hamburger, a small little handful of fries, maybe a couple tablespoons of ketchup. And then currently what's actually served is a huge hamburger or cheeseburger. It's twice as much. It's a 1/2 pounder versus a 1/4 pounder. French fries, you get almost double the amount, way more ketchup. People don't think about it, but ketchup actually has a lot of sugar. And total, it's almost twice as many calories and close to twice as much fat. So it would be easy to eat that meal in one portion, and you would be getting over half your daily calorie recommendation. So one strategy is when you go out to eat, split the meal, make it like the portion should have been 20 years ago. Cut the hamburger in half or cut the cheeseburger in half, and you each eat half, which is actually the size that we're meant to eat. More portion distortion pictures. This came from one of my favorite magazines. It's called Nutrition Action Magazines, and it says servings on steroids. And so it's looking at previous servings versus current servings, and it has different calorie amounts at restaurants that you guys have probably eaten at. So brownie, 380 calories currently versus 180. Panera bread sandwich. It's a Sierra turkey sandwich. Look, it has lettuce and turkey. It looks like it's made on a fresh panini. It looks super healthy, 730 calories. Five Guys fries. They just built a Five Guys in town. I recommend against the basket of fries. It's close to 1,000 calories when a serving should be 200. The orange juice. A serving of juice should be 8 ounces. What they'll serve you is 3 times that amount. And so juice actually has a lot of calories. A lot of people consider juice to be a healthy food, and it can be, especially if you're doing juicing with multiple fruits and veggies. But generally, juice can be a lot of sugar and a lot of calories. So you'd be better off eating just a plain orange. More serving sizes, McDonald's shakes. You know, you're driving home again, you stop for a snack. Oh, I'm just going to get a McDonald's shake. That sounds good. Something cool, refreshing, wake me up. 700 calories later for only 16 ounces. Oatmeal raisin cookie, oatmeal, whole grain, raisin, fruit. That sounds healthy. 400 calories. Grilled quesadilla. I'm guilty of getting things like this at restaurants. They're delicious, but 820 calories. Meats. We should have 3-ounce portions of meats, which are very, very small. They're about the size of the palm of your hand or a computer mouse or a small cell phone, not a big iPhone. But what's served is a lot higher than that. Pizza, pancakes, harvest grain and nut, those sound healthy, but again, 820 calories just for the pancakes, and then people add butter and syrup and who knows what else. So being aware of portion sizes is really important to overall health and diet planning and portion control. And later in the class, you guys are actually going to record a 3-day food diary intake of everything you've eaten and drinking. And so using some of these portion size guidelines can help you to estimate what it is that you're actually consuming, you know, how many cups or how many ounces, etc. And we're going to see some more of these coming up. Dietary guidelines for Americans. So every 10 years, our government comes out with something called the Dietary Guidelines for Americans. And in general, they provide physical activity and nutrition advice to make us the healthiest that we can possibly be and try to help us improve our health span or years of life where we are healthy and free of disease. They are revised every 10 years based on scientific information, and they are created by a panel of experts. And so there's different guidelines. There's hundreds of guidelines. Usually this document is hundreds of pages long. But for example, they have guidelines to reduce chronic disease, to reduce food insecurity, to reduce obesity, to reduce preventable diseases, to lower smoking, lower alcoholism, increase prenatal care, different things like that. And so some of them are general health recommendations, some of them are physical activity recommendations, some of them are more specifically diet recommendations. These are some examples of the dietary guidelines for Americans. And some of the goals involve balancing calories to maintain weight, foods and food components to cut back on, and foods and nutrients to increase. And so I do want you to be aware of some of the different components of the dietary guidelines for Americans. And we're going to see specifically foods and foods components to increase and reduce on the next page. Additional guidelines include increasing physical activity time and reducing time spent indoors doing sedentary behaviors such as video games or TV or what we call screen time. So foods and food components to reduce and also increase. So on the bottom, we have foods and food components to reduce. Calories from sofas. What the heck is a sofa? I like to think of a sofa as a couch potato. If you eat a lot of sofas, you will look like a couch potato or somebody who's kind of obese and unhealthy. And sofas are saturated fats and added sugars. So it's recommended that we cut back on those. Refined grains are grains that have been milled and their outer husk, as well as the portion that contains the fiber and many of the nutrients has been removed. Sodium, otherwise known table salt, saturated fat. So all of these foods that we should limit, we're actually over consuming. And then on the top, these are foods that we should increase, and you can see we're not consuming enough of them. So none of the foods that we should increase are we actually meeting our goals of. And I will say a tiny little disclaimer about saturated fat. There's more and more research coming out every day that possibly diets that are high in saturated fat are not as unhealthy as they previously thought. So there's kind of a new wave of thinking that diets high in saturated fat actually can be okay, and diets high in fat in general can be okay, where in the past there was this huge low fat kick. We still believe that trans fats are bad, but there's a little bit more research kind of coming up about saturated fats. Foods to increase, these were summarized in the tables. So specific nutrients to increase: potassium, vitamin D, fiber, and calcium. And we can get these things from some of the foods listed here. Physical activity recommendations. So it's recommended 150 minutes per week of moderate physical activity. If you're on the Cal Poly campus, you definitely do that by walking around. I know our campus is very big and hilly. I usually do 2 to 4 miles a day just on campus. And then for children and adolescents, 60 minutes a day. Do you think that they get that in schools? Unfortunately, no. And so it's really important that parents and after-school activities, sports teams, etc., can play a role in helping children to get extra physical activity after that classroom time. My Plate. So My Plate is also created by our government, and My Plate is a tool for menu planning. You can see it looks just like a plate, and there's portions of the different foods you should have represented by different colors. I mostly like My Plate. I wish instead of dairy, this would say maybe dairy or dairy alternatives. But otherwise, I think it's pretty good visual. And you can actually go to the My Plate website. It's loading here, and you can get all sorts of emails. You can get information about fruits, vegetables, online tools, serving sizes. This is really good for estimating how much you need. What is a cup of fruit? So exact measurements of what serving sizes are, etc. And there are all sorts of great tools on My Plate. There's a BMI calculator, there's quizzes, you can do a portion distortion guide, all sorts of fun things. So I would recommend that you guys go on My Plate and just check it out. It's a great tool you can recommend to friends or family wanting to learn more about nutrition, track their intakes, burn calories, etc. So that's My Plate. And how did we get to My Plate? So when I was a kid, we had the food pyramid. And I actually personally liked the food pyramid. I thought it was a good visual. Whether or not all the foods that are on the bottom, which are carbohydrate-containing foods, should be that big of a base, I think the evidence is a lot more mixed now than what we thought in the 90s. On the very top was fats. After the food pyramid, we transitioned to this mypyramid.gov. I did not like mypyramid.gov because it just has these vertical striped colors, and you don't know which foods that those represent unless you go look them up, like online or in a book. So it doesn't actually tell you which foods to eat more of. The thing I do like about it, however, is there is a person exercising, and so that's very important. And then now we have the choosemyplate.gov, which is a pretty good visual. There are all sorts of other pyramids out there. There's vegan pyramids, vegetarian pyramids, Mediterranean pyramids, different pyramids for different religions, different countries. There's Native American pyramid, etc. But these are just a few of them. Messages from My Plate. So do be aware of some of the messages from My Plate. And these messages are not written on the plate, but if you go to myplate.gov, you can read some of these messages. A big important one is making half your grains whole. So there's a big push to move away from refined grains and added sugars towards whole grains so that we can get more fiber, more vitamins and minerals. Drinking water. And then what counts as a serving? So there's some great information about serving sizes here. 1 cup of fruit is a serving, 1 cup, which is 8 ounces of milk, yogurt, or soy milk. 1 ounce of meat is a serving. That's tiny, tiny, tiny. 1 egg is a serving. And so you'll want to use these types of guidelines when you record your 3-day intakes. These are some other portion estimation tools. So for example, 1 cup of fruit is about as big as your fist. A half cup of vegetables would be about just the palm of your hand. 3 ounces of meat, a deck of cards. A quarter cup, a golf ball. 1.5 ounces, 6 die. Just the top of your thumb, which we all do have different size thumbs, but approximately a teaspoon. There are some more portion sizes here, so you can see what an actual recommendation of cereal is, which is usually a cup or less as recommended on the serving sizes. Pay attention to those. And then what people are more likely to actually pour. So 1 2/5 cups or 3 2/3 cups. And then again, some more portion size estimates. So this is using tennis balls as 1/2 to 2/3 cup and baseballs as 1 cup. This is an example of the Mediterranean diet pyramid. I like the Mediterranean diet pyramid a lot more than our particular food guide. So it has a much diverse base. It also has a different base. So it has socialization, exercise, family time, eating family meals, dancing. And then on the side, it has drink water, which ours does not have. And it also has wine in moderation. So who's going to argue with that? I particularly am a fan. Evaluating nutrition information. So part of this class is going to be evaluating nutrition information. And one thing in particular you're going to evaluate is fad diets. When we look on the internet for nutrition information, we're flooded with different sources and different advertisements, different opinions out there. But it's really, really important to do your research and thoroughly investigate which web page or which blog or which article you're reading and ask some questions. You know, who wrote it? What is their education? Where did they get their information? Are they citing their sources or are they just free writing? Does what they're saying on their webpage agree with the guidelines for Americans? Are they promising things like 10-pound weight loss in 2 days, or cure your cancer with this magic pill? So it's really important to kind of evaluate and ask questions before taking what is said on a webpage as the truth. Additional questions to ask. Are their findings based on a study? And if so, what type of study? How many people were in it? Was this study based on employees of that particular company? Was it based on 1 person? Was it based on 1,000 people? Did they do a nutrition assessment? Are they recommending doses of supplements that might be above the upper limit? So all of those things are important to ask when evaluating nutrition information. And then last but not least, this is just a hint to some of the factors that affect nutrient composition of foods. And we're actually going to dive into this a lot more in chapter 3. So if you read in your book, chapter 2 introduces it, but we're going to talk a lot more about it in chapter 3, which will actually be our last chapter of the quarter. So I want to thank you guys for listening today, and sorry about my few little technical things with the pages, but I will talk to you next time. All right. Thanks. Bye.